So remember how we do the questions. We don't have too many questions in chat, but we will open it up. You raise your hand and I will call upon you to ask the question. But in the meantime, David, we had a question about if you add gypsum to the wastewater, can you mitigate the sodium concentration effect on the trees and the change in soil structure?
David.
Yeah, I'm starting my video. Yeah. The rationale behind it would be that the gypsum would bring us calcium with it to counter the sodium effect. And yes, that was a treatment that we considered to alleviate the damage in the experiments that we did to alleviate damages. I can't remember at the moment what prevented us from doing it. There is the consideration of salinity. So if we add a lot of gypsum, as far as I know, the sulfate can get to a level where it does increase salinity and can damage the avocado trees. And that's what I'm familiar with. But yeah, that's also a promising direction for solving the issue. Yeah.
Hey, Ben, do you have a comment on that since you've worked with gypsum?
Yeah, and that's perfectly true. I mean, gypsum is a salt. It's going to increase the salt load, and it's always a balance between trying to mitigate the sodium effect. So it's important to realize that a lot of people apply gypsum if they have a salt effect without regard to the sodium, and it's only effective if it is used with a sodium affected water or sodium affected soil. So we use gypsum way too much, but it can be used very effectively when we do have sodium affected waters and soils. So I don't know how much to use though.
Thanks, Ben. We had a question earlier, and this is for you, David. So this is a sort of a long question. It says, what does a water analysis reflect of the treated effluent water? That's question one. Elevated levels of chloride, sodium, boron, or nitrates. If boron and nitrates were lower, could the chlorides and sodium be managed reasonably by blending the water with groundwater or fresh water? I guess it gets back to your question about blending. And your data that you showed saying when you had a 1-to-1 mix, it wasn't that effective.
Yeah, so the 1-to-1 mix we used in an avocado orchard that was already showing signs of damage. So the mix was not so effective in recuperating the damage, but we did see this is still data that we're analyzing at the moment to see if there was any improvement in yield there, because the trees do look a little bit better with the mix. So yes, as a general rule, blending might be an option that can improve the situation. Yeah, we do see it as a promising way to go in the future with this. Yeah.
Thanks. So we'll open up the, we have, Ben is writing, rather than blending, can it be more effective to alternate your irrigation between fresh and reclaimed water or wastewater?
So yeah, that looked like it's very promising. So we're currently trying to publish a paper that wasn't so successful the first time around, but summarizing the effect on the soil. And what we see is that 1 year of irrigation with fresh water was basically almost absolutely restarted the soil already. So yes, it might be useful to do 1 year of recuperation of the soil conditions, return it back to treated wastewater. On the technical level, I imagine that's very challenging for a farmer to do something like that, because once he's got the infrastructure for irrigation with treated wastewater, converting again to fresh water would be challenging, I guess.
Very good. There was a question about whether the rootstocks that Salit talked about are commercialized in California. As you probably are aware, commercially available now are VC 66, 801, and now I gotta remember 218, I think. We don't, the 152, we do not have in California. I went and looked at the list of the VC rootstocks that we actually have in California. We don't have the 152. So we're out of luck there. But the question I would have for you, Salit, is how widespread is the use of these VC rootstocks in Israel? Because I've always been under the impression that people are more inclined to plant ashstone, Degania, these seedling rootstocks.
Yeah. The old orchards are of the seedling rootstocks, Degania and Ashdod and Shiloh. But the new ones are, many of them are on clonal VC rootstocks. And it depends on the nursery stock. We hope that now, because of our research, there will be more attention to the specific rootstock and not just what the nursery has.
So is the 152 planted commercially, or is it gaining traction based on your research in Israel?
I don't think that specifically this one, but others from the tolerant, I think that VC 320 is highly commercial in Israel, and maybe 159 as well, but not 152. Not yet.
Great. So we have a question on using leaching irrigations. Is that used in Israel to reduce soil salinity? Is to do leaching irrigations?
Yeah, so it's a bit tricky because once we've got the solidity effect, so that keeps the water kept up in the topsoil, and then these excess water amounts are not so effective at taking the water down below the root zone as we would like to do in a leaching irrigation. And so yes, it is commonly practiced. I think we irrigate with 30% as a rule of thumb. Salit, can you correct me if I'm wrong about that?
Again, what?
That it's about that it's common practice to irrigate with about 30% in excess to leach some of the salts out. I think the number is 30%
not in
as far as
orchards.
my.
It's more in when you're speaking about pots in the nursery or something like that. I don't know this practice
Okay.
in an orchard.
Okay, I've heard it previously from farmers also. So yes, it's done. The effectiveness is a bit limited once we've got this solidity effect. So that's the problem of it. Yeah, that's what I know to answer about that.
Yeah, we have another question about water softeners. I don't know if you use water softeners in Israel, but at least in California, we have what we call hard water. And so it's very common to use a water softener, and that puts chloride and sodium in the wastewater. And now there is regulations controlling the use of water softeners. What's in Israel? What's the practice in Israel? Do you even use water softeners?
Yeah, so they are used, and that's a great source of sodium and chloride. Also, I wanted to share an anecdote that for our kosher meat, one of the processes that meat goes through to make it kosher, to make it correct according to Judaism, is to add a lot of salt to it. And that used to be
Take off the blood.
The slaughterhouses used to be a great source of salinity in the past, and now there's quite strict regulations on them having to concentrate their sewage so that they don't emit it out to the main wastewater. So they collect it and they have to throw it basically into the sea together with saline water. Another step that has been done in Israel is about the boron in the washing material. So basically that was identified as another source of excess boron in treated wastewater. And there's been a move to take out boron from detergents where it's commonly used and replace it with phosphorus-based products. And there's strict legislation on that. So yeah, so there is some thought also about the source emitters.
Thank you. So do we have any question? I haven't seen anybody raising their hand with a question. Is there any questions out there? Oh, we have one question that just came in. It's for you, David. Do you have any information on the impact of consistent use of mulch around trees to mitigate the negative impacts on the soil structure that you talked about?
No, I'm afraid I don't have. I mentioned that this experiment that we're doing now with avocados, with using pumice, what we're doing is that we're using ditches filled with pumice and irrigating over them. And another experiment that's been running recently by our colleagues, there is a student named Yusra Khalil who is working on that, where they tried ditches filled with different compositions of compost as a way to aerate the soil. But I'm not sure they got to any conclusions. That wasn't done on avocado, that was done in almonds. I don't know what their conclusions were so far.
Yeah, mulching is a very common practice here in California because of the fact that it helps also retain soil moisture, and the roots will grow up into the interface between the soil and the mulch, presumably because one of the reasons is for the oxygen. So we had another question here. We got a couple questions coming in. So let me, one question for you is, do you think that enriching reclaimed irrigation water with oxygen might be beneficial for the trees?
So in a pot level experiment, I'm sure it does. There's been a Nepalese student here that did this, Indira Paudel, and she's published this, showing that when she she used aquarium pumps just to pump in oxygen to potted plants irrigated with treated wastewater, and she saw benefits from it to root growth, and I don't think she grew them until they gave any yield, but she saw some significant effects on root growth. It's always a question of how effective we can do that in the field. There has been some experiments with nanobubbles and things like that, but I don't know that they've had some amazing results, life-changing results. As a general practice, not only in treated wastewater, I would recommend any practice that would add oxygen to trees. So one of our collaborators, Ran Arel, has been growing trees on this white material, perlite, with a commercial name. And he's been seeing the trees growing just tremendously, just from the fact that they have, it seems, much more oxygen than they do in proper soil. So I do recommend any practice that's actually getting the oxygen into there. But the question is whether the oxygen will get there if we pump it through the pipes or not. So yeah.
So we have a question for you, Salit. Are the yield results on the rootstocks that you presented similarly with reclaimed water would be similar if you had lower levels of salinity? So the ranking, the relative ranking.
When we compared the yield of the rootstocks, of the different rootstocks under fresh water and under the treatments, we saw that the tolerant ones kept their performance, and the ones that were susceptible, we saw a significant decrease in the yield.
Oh, good. So we have a question about rootstock breeding in Israel. Is anybody, what's happening with the breeding of new rootstocks? Or do you have so many rootstocks left over from Dr. Benyakoff that it will still take many years to go through those? The real question was, is GMO being explored in Israel to develop superior rootstocks? But what is really happening with the rootstock program in Israel?
I don't know. I know that there is a specific nursery, and I'm not sure if I'm allowed to say names of nurseries here. So I know of one nursery that is working on breeding, on polyploidization of rootstocks, and some of them are commercialized. But we have a really big collection of Professor Benyakoff.
So you would say they're really sort of still underutilized, or we have a lack of real knowledge about many of the rootstocks that Dr. Benyakoff selected.
Yeah.
Yeah, I mean, I know that his program wasn't so much appreciated when he was still very active working. It's only now later that it's more appreciated what great contribution he made to the world, actually.
That's right. And we have nowadays many works regarding his rootstocks, regarding how it's called, verticillium, and Phytophthora, and salinity, and other things. And we all use the same collection of Benyakoff. He did a great work, so we only add a bit.
Yeah, so do we have any other questions that people can want to ask? I don't see anybody has raised a hand this time, because we have two people here that are providing us I mean, we could say we don't use reclaimed water in California, but I think the trend is, we know that down in Escondido, there's a movement to use reclaimed water. In Irvine, we're using reclaimed water at the university field station. So it's not without, and I think with the drought that we have in California, there'll be increasing pressure that we'll be using reclaimed water or wastewater more and more in agriculture. So
I think if I can comment on that, what I understood from, I tried to mention that in my presentation, what I understood from a talk of Professor David Sedlak here is that you've got a real challenge in California with the fact that you've got a mountain range separating between your agricultural areas and your urban areas, so that makes it very difficult to pump the treated wastewater over to agriculture areas. That's perceptually what I understand. But please correct me if I remember incorrectly, Mary.
I'm sorry about my dog barking, but it's partially true. We have a large mountain range that separates the San Joaquin Valley, but where most of the avocados are grown in California is on the urban interface. And so we have avocados and actually still a lot of citrus intermixed with in Southern California. And so there's competition between the need for irrigation water and the urban need, and we're coexisting. But now I see we have two raised hands. So Greg, why don't you ask your question first? You were the first one to raise your hand.
Thanks, Mary Lou. I didn't catch Salit's answer. I asked the question about the rootstocks giving similar results with fresh water. Did she say that I heard her say that the tolerant rootstocks still yielded well under fresh water, but did she say that the other rootstocks that were susceptible, did they show a significant increase in yield, or were they still very low?
No. Under the salinity, they had a real decrease in the yield. Under the fresh water, they were very good in their yield.
Okay.
The VC, the most susceptible rootstock was very good in its yield under fresh water.
Okay, thanks.
John, you have a question?
Yeah, Mary Lou, I'm curious, the conditions at South Coast, where you've been using reclaimed water for quite some time, would you characterize that as a sandy soil or a clay soil or loam, or how would it compare to the work that's been done here in Israel?
The soil at South Coast is like 50, 60 feet sandy loam.
So even in a sandy soil, you can see significant problems.
Oh,
Use-
yeah. I mean, it's, what I can tell you is that the trees look healthy. They've done a really good job. They have new management at South Coast. So you would look at the trees look better than they did 15 years ago in terms of leaf burn and things like that. But overall, the things that and I don't know if it is quote climate change or what it is, but what we're seeing is the yield has been slowly going down, down, down. The other thing is the fruit maturity. The fruit don't hang on the tree as well as they used to. Varieties that we thought were, you wouldn't pick until August, they're finished in July. And so there's changes, and that is that climate change, or is that the effect of the long-term effect of the reclaimed water? I really don't know. I can tell you though that in the post-harvest work we've been doing the last 2 years, compared to storage tests that we used fruit from many years ago, I don't think the storage potential of the fruit is as good as it was 15, 20 years ago. And why, I don't know. I like to, I only go back to many years ago, Gary Bender did a reclaimed water project in Escondido. And we stored fruit from there. He had a fresh water, a 1-to-1 mixture, and then the reclaimed water. The reclaimed water was really bad, David. It was really high salt, high everything. The trees looked horrible. But in that study, I did a storage test for him, and the fruit that was in the reclaimed water, the 100% reclaimed water, had no storage life. The fruit from the 1-to-1 mixture was intermediate, and the best storage quality came from the fresh water. So it could be that we're seeing that effect. I really don't know. But there is a change. There is a change. And it's more drastic than when we've tried storing fruit from other locations where we have trees.
Are they seeing these same characteristics and using reclaimed water in Israel?
You mean in terms of fruit quality? I don't know. That's a good question.
I can say about our research, because most of the orchards in Israel are irrigated in wastewater, in treated wastewater. We don't have orchards on fresh water, but in the research, in the experimental orchard, we saw that under salinity, we had a bit smaller fruit, but it wasn't significantly smaller. The weight of the fruit was a bit lower than under fresh water, but the overall quality of the fruit didn't change.
So did you do
I want
storage
to-
tests on the fruit? Or
No.
did you store the fruit?
No,
Yeah,
no.
well, see that you only see this difference when you store the fruit. You have to store the
Okay.
fruit for like 2 or 3 weeks, like you would if you're exporting the fruit into Europe. And that's where you see
Yeah,
the effect.
our research group is not working on post-harvest, so only on the tree physiology. So.
Well, you need an integrated
Our-
research team. That's what
Yeah.
I would say.
Our team did have someone working on this specifically. Our hypothesis was that perhaps there's insufficient calcium in the fruit, and I know that calcium is part of the ethylene, right? The ethylene secretion
Yeah,
from the fruit to mature. So we did see differences in the calcium in the fruit, but we didn't see any effect on the ethylene when he did these tests. That was Adolfo Levin that worked on that. I think it was included in his PhD work. But we did it once, and once he didn't see any results, we didn't repeat it further. But yeah, perhaps there is something there.
The only thing I would say is that you have to look at it through the harvest season, because if you just divide early, mid, and late fruit, that also influences the response. So the most susceptible fruit is the late season fruit. So, you know, it would be the fruit that you're picking for you, I know, would be the Hass fruit you're picking in March and April at the end of the harvest season would be the ones that would be the highest risk for issues if they're compromised. But I see we have Ganesh has his hand raised. Ganesh? We can't hear, you're muted, Ganesh.
Hello.
Hi.
Hi, I'm Mr. Ganesh from India. Yeah, and I am avocado grower. My question is there is compulsion of use of fresh water for avocado if water is normal.
Could you repeat the question, please?
Fresh water is compulsory use for avocado is necessary.
Is fresh water
or distilled water? Distilled water is compulsory to use in avocado.
for
irrigation?
avocado? Well, the avocado is very susceptible to salinity, I think, as what you've seen from these presentations. So the higher the water quality, the better off you're going to be.
Yes. Okay. Thank you.
Welcome.
There's some very interesting work of Nel Silber. I should mention that we have some real clashes here in Israel over this topic of treated wastewater, and there's a group of Avner Silper that is irrigating with very high quality water. So he's using reverse osmosis and using this water to irrigate the avocados. And he says this is a secret to raising yield, and he claims that it's even financially worth it to take the treated wastewater, even go through reverse osmosis, because the increase in yield justifies it eventually. And they also raise another concern regarding the long-term effect of leaching and washing out the salts, because that's a time bomb leading us to wash down the salts down to groundwater and eventually leaving it for our children and grandchildren. So I think this should be also mentioned in the greater discussion about using treated wastewater, that it does add salts that we don't know how to get rid of yet.
So I have a question for you in terms of reverse osmosis. You generate a lot of brine. What do people do with the brine when they have reverse osmosis in Israel?
It's thrown back into the sea. There's the brine. There's a pump that pumps it right out again. Because our reverse osmosis is from the sea mainly, so it's located close to the coast, and it's pumped straight back to the sea. Brian.
Great. Do we have any other questions? Anybody have any other questions for our speakers today? Oh, here. What are the energy costs in Israel? RO uses a lot of energy, so it may not be justified here in California or in Israel. I mean,
yeah, in the greater picture, it is a problem. So, generally speaking, what we do is that we use electricity for reverse osmosis during the nighttime. So that the electric system has to go running non-stop, and that way it's some kind of efficient use of electricity. But yes, I think that's a good question to ask. I think we're relying something like half of our drinking water comes now from reverse osmosis, so it's
it depends on the area in Israel.
Yeah.
So Greg, I see you have your hand raised again.
Yeah, I was just wondering if anyone can give a clue about whether the method of irrigation would matter when using poor water quality. I'm thinking of drip versus micro sprinkler.
We're using drippers.
All the trials were with drippers?
Yeah.
Do you think there would be any difference in the effects of using drippers versus micro sprinklers with poor water quality?
Yeah, so we thought that dispersing the water over a larger area of land might be more useful. We didn't use micro sprinklers. I don't know whether the water quality wasn't good enough for that. So one of the reasons why we use drippers is to avoid contact between the wastewater, the treated wastewater, and the farmers. That was a consideration not to use sprinklers. We do think it would be beneficial with our study for the oxygen, but we didn't experiment with it yet.
I had one question for you, David, that came up early on your talk, and I forgot to ask it to you, is that you talked about contaminants in wastewater, and one person asked about microplastics. Do you have to worry about microplastics in your wastewater?
I'm laughing because it's such a big topic, isn't it? I mean, also the health risks that I was talking about pharmaceuticals. I don't think it's something to lose sleep about, but I think it's important that there are studies on it, and I think it's important that we realize that it's happening. I don't think we're in a stage right now that I think that unless we drink reverse osmosis water, we can't avoid getting microplastics. So it's everywhere. And even without treated wastewater, if we're irrigating with drip irrigation, we're getting microplastics. It's there. And it's in all water sources, so we can't avoid it. So is it part of what's causing us to be less healthy nowadays? I don't know. Yeah, I guess it's somewhere there as well.
Thank you. Ben, you have a comment?
I want
Oh,
to add regarding the sprinklers that in another work of us regarding the canopy cooling, we saw that when we use the wastewater, the treated wastewater in sprinklers, there is a layer of salts that remains on the leaves, and it's not good. It burns them. So the drippers are better, I think.
That's a very good point. Many years ago, we were looking at that, and we were working with Jim Oster, who used to work. He was a extension specialist with UC, but before that, he was a researcher with the Salinity Lab in Riverside. And I remember he was very concerned about the idea if you do overhead misting or cooling of the trees, what it would do with the salt deposits on the leaves, especially with avocados being as salt sensitive as they are. So Ben, you had a comment?
Yeah,
Question?
Greg Alder asked the question about the difference between drip versus micro sprinkler. With drip, you get a nice even pattern of salinity moving out to the fringes, and it's pretty well, you know, it's an even displacement that occurs. With micro sprinkler, you get this really uneven deposition of salt that is with distance from the emitter, it increases. So actually you have to put a whole lot more water on with a micro sprinkler to reduce the salinity within the root zone than you would with drip. So it's much more efficient at salinity management.
Right. And how about this idea then of the mulch and using more mulch maybe to counteract the wastewater effects? Ben? Sorry.
No, I would think so. I don't know that for sure.
Okay. Well, David, you've raised your hand, David. Do you have a?
Yeah. About the mulching, now that you mentioned it again, then I just wanted to say that we always see in avocado quite a thick mulch, don't we? I mean, the leaves make a very, at least that's what I'm familiar with here, is that they make a very thick layer on top of the soil. And we don't see so much of a positive effect for that, but I guess mulching properly might do a different effect. And I wanted to ask, what's your own take from your experience in California about the microplastics? Is it something that's concerning you guys, or do you hear a lot about it as a subject of concern?
Well, it's talked about that in the pharmaceuticals. It's definitely talked about. The last time I went to an American Society for Horticulture Science meeting, they had a whole symposium about it, but no one really has any answers for it. So I think, as you said, it's out there. We know it's out there. Is it something you need to lose sleep over? I think the jury is still out on that one. So we have a question here. What would be the recommended maximum chloride milligrams per liter threshold in wastewater analysis be? So if you, I guess if you could make the big decision, what would you lower that maximum chloride that is allowed in that you would see? And then, in other words, what level of chlorides and sodium would be too high to consider growing avocados in a treated wastewater?
Depends on the rootstock, of course. If
Sure,
you have a tolerant one, then you can use the 280 that are the regulations level. But,
well, I mean, we have a lot of acreage in California on Dusa.
wow.
So if it was Dusa, what would you say?
Well, she suffers in 280. I don't know. I didn't check less than that, so I can't say that's and that's not. But she suffers in these levels.
Yeah.
You know, at the first year, she was really good, Dusa. The first year of the salinity, we didn't see any damage visually or other, but we saw it has high levels of chloride and sodium in the leaves. It was strong enough to not show the damage, but after 2 years and about 3 years afterwards, the defoliation of Dusa was the worst of all the rootstocks. So it kept it in the leaves, but it suffers.
And so I have a, what is the soil pH in Israel? I mean, are you dealing with basic or acidic soils?
Alkaline soils as a general rule. Do you have a number to show? Between 6.8 and 8.
In our orchard, it was 7.8.
Oh my God.
Oh, that's really high. Maybe that's why Dusa didn't do so well.
Yeah.
Okay. That's why
yeah.
it's very important to write in the materials and methods and the exact conditions that the trees were grown on.
Yeah. So, very good. Do we have any other questions from anybody? Because I'm sure we could chat away, but we want to make sure that if anybody has a question that is being asked either through the chat. Oh, here we have one here. We have 2 questions. Any chance that California growers can get some of the promising rootstocks anytime soon? So I can answer that one, John. They have to be introduced. Anytime soon is the qualifier there, because now any plant material coming in from another country, if it comes in conventionally, budwood, then it has to be grafted and go into quarantine for 2 years. And while that material is in quarantine for 2 years under very strict guidance, you're not allowed to do any propagation. Now, I've been told, I understand that you can also bring material in tissue culture. So if someone's taken some of this more promising material from Israel and they can introduce it into California under tissue culture, then it still has to be in quarantine for 2 years, but you're allowed to do some level of propagation. So you probably, and then you would want to test it to make sure it does well in California. So you're probably, if we were to introduce VC 152 into California today, it probably would be 8 to 10 years probably before we could have it commercially available. And then in this era of intellectual property, you would have to have someone who would be willing. We can't just bring it into the university anymore and then release it. It would have to be, someone would have to work out an agreement with the government in Israel that controls the VC rootstocks and be able to have it released. So I think it would be worthwhile to get some other material in California for evaluation, but for the commercial release, we're looking at quite a ways away. But we have a question here. Can Ben Faber please clarify the remark on salinity with drippers versus micro sprinklers?
Yeah, just think there's a ring that moves out from a dripper. It's consistent. So the salinity ring is at the edge, whereas with a micro sprinkler, with distance from the emitter, you get less and less water. So the concentration of salt increases as you get with the distance from the emission point. So you get this wetted pattern out there that when you get out, not too far from the emitter can be really, really high in salinity to the point that the roots can't take up that water. And so you have to put on a lot more water in order to leach that salt through. So drippers inherently have a greater efficiency and greater potential for efficiency if they're well maintained. And when they clog, they're a mess, but when they're brand new and well designed, they're great.
Oh, great, Ben. Do you have any closing comments, Salit or David, that you would like to leave with the group today?
Choose your rootstocks.
Okay, very good.
No, just thank you very much for your attention. And I'll be very happy for, if anybody wants to contact me with other questions or ideas, I'll be very glad for that.
Well, that's great that the contact information for both David and Salit are on Avocado Source if you look at their CVs. And before we close, maybe Ben, maybe you might tell the group what we're going to cover in the next session, since you're the one that is going to organize that one.
Yeah, it's going to be going back to basics, and this may answer the question that Lynn Curtis asked about drippers versus micro sprinklers. Stu Stiles is a researcher and consultant at Cal Poly San Luis Obispo who is co-founder and director of the Irrigation Research Center there. He's going to be talking about, the basic fundamentals of, plumbing, how irrigation systems work, and how they perform and how they're rated. And then Jamie Whiteford, who's with the Ventura County Resource Conservation District, is going to talk about maintenance of irrigation systems and the need for maintenance and why we have terrible irrigation out there, because we have terrible maintenance, and God damn it, let's get on top of these things. It's the worst thing we do out there is irrigation. So you're going to hear about how to do it better.
Well, great. So that'll be in about a month. About a month.
Yeah,
So
yeah,
stay
in
tuned
August.
for when that date is. And I want to thank all of you for attending today and for the great questions that came through on chat and through just raising your hand. So we'll see you in about a month, and stay safe and healthy. Thank you.
Thank you all. Bye-bye.
Bye-bye. Have a nice day, guys.
Yeah, thank you.